Hello students, I'm Amit from Minerva. So today we are going to start study chemistry, and as we are doing the chapter acid, base and salts, we have already completed acid and bases, and right now we are going to start our portion called salts. And we all know that how salts are prepared by neutralization reaction between an acid and a base. When an acid and a base reacts, a neutralization reaction occurs and a salt is formed, right? So a salt is basically comes from the combination of acid and base. Okay, so we know that in an acid, for example, HCl you are taking, okay, and base you are taking NaOH. Okay, so here we are getting Na plus. This is the basic radical, okay, and we are getting Cl minus, which is the acidic radical. Okay, this is the acidic radical, and this is the basic radical. Okay, so salt is formed between the combination of acidic and basic radical, right? So we will get what? NaCl. Okay, so we are getting this salt as NaCl. So now we'll see what are the different kinds of salts. And before going that, I want to again refresh your mind regarding the basicity and acidity, basicity of acids and acidity of salts. Okay, so we know already that basicity means, what do we mean by basicity? And basicity term is used for the acids, basicity of acids. Okay, so what is basicity of acids? Number of replaceable hydrogen, right? And acidity of bases. What is acidity of bases? Number of replaceable OH minus. Okay, suppose we have copper hydroxide. Okay, so there are two OH groups are present which are replaceable, right? So this is diacidic base. Okay, so if you are taking ferric hydroxide, this is ferric hydroxide, so we are getting triacidic base. Is it clear to you? And in case of acids, we can say HCl, which is a monobasic. Why it is monobasic? Because one replaceable hydrogen is present, right? H2SO4, H2SO3, both of them are dibasic acids. Okay, so we have to clear this concept first to understand the different type of salts, right? How different types of salts are formed. So we are going to the different types of salt that are formed. So the first type of salt is normal salts. What is normal salts? Normal salts is where no H and OH, H plus and OH minus are present. Okay, the salts where no H plus and OH minus are present. So we can also say that, like, these normal salts are formed by acids, for example H2SO4. Okay, H2SO4, what kind of acid is this? Dibasic acids. Dibasic acid, it means it has two H plus ions which can be replaced, right? So if all the H plus, if all the hydrogens of an acid are replaced by another, okay, so if all the hydrogens of an acid is replaced by basic radical, then we get a normal salt, right? So what are basic radical? So basic radical is metallic, for example Na plus, K plus, Ca2 plus, these are all basic radicals, right? The metals carrying positive charge, these are basic radicals. So if in an acid, suppose this is the acid, H2SO4 is the acid, we all know. So if the basic radical completely replaces all the H plus present in the acid, then the salt form is known as normal salt. Okay, so if these two H are replaced by Na, right? If these two H plus are replaced by Na plus, what we will get? Na2SO4. Okay, so this kind of salt is known as normal salt. Simple. It can be produced like this: H2SO4 plus NaOH. Okay, so we have to take 2 moles of NaOH so that it can replace 2H plus from the H2SO4, and hence we will get Na2SO4 plus H2O, right? So to form normal salts, complete replacement of H plus is needed, right? Complete replacement of H plus is needed from H2SO4 by another basic radical like this. Okay, so when there is complete replacement of H plus by a basic radical from an acid, we get what? We get normal salts. It can be like this: KOH, 2 moles of KOH is reacting with 1 mole of H2SO4, and hence we'll get K2SO4 plus H2O. This is also a normal salt. You can also identify a normal salt like this: when there will be no H present, H or OH present, then that salt will be normal salt, right? So now we'll see another kinds of salt. The second kind is known as acidic salts. Second kind is known as acidic salts. So it is clear from the name only, like, right? So we can say salts where hydrogen is present, right? The salts where hydrogen is present or H plus is present, that salt are known as acidic salts. Okay, for example NaHCO3, NaHSO3. Okay, these are all acidic salts. Okay, so how acidic salts are formed? Again, we are taking the example of H2SO4. Okay, so instead of replacing 2H plus, if only one H plus is removed by another basic radical, for example, we are taking the basic radical as Na plus. So if one Na plus only replacing one H from this acid and one H is already left for the salt, okay, then we will get an acidic salt, because in the salt one H will be left. The total replacement is not occurring here and we are getting an acidic salt. Okay, so we can say partial replacement. Partial replacement of H plus from an acid by basic radical, right? So if partial replacement of H plus is occurring from an acid by basic radical, we are getting what? We are getting acidic salt. And the condition needed here is that if we are taking monobasic acid, for example HCl, monobasic acid cannot be used to prepare acidic salts. Monobasic acids cannot be used to prepare acidic salts. Why? Why it cannot be used? Simple logic, because it has only one H plus present, right? So if one H plus is present, then complete replacement is possible. Okay, no H plus will be left for the salt, right? So monobasic acids cannot be used to prepare acidic salts. What we need? Dibasic salts or tribasic salts. Okay, for example H2SO4, this is H3PO4, tribasic salt. Okay, so we need dibasic salt or tribasic salt for the formation of acidic salts, right? So we need dibasic or tribasic acids for the formation of acidic salts, right? Is it clear to you? Now we are going to see what is basic salts. The third category of salt is basic salts. Same concept will be used here. Suppose there are many bases, calcium hydroxide, copper hydroxide, ferric hydroxide. Okay, this is diacidic base. Diacidic base. This is also diacidic base, and this is triacidic base. Okay, so even basic salts are also requires more than one OH minus in the basis for its formation. If you are taking NaOH, which is monoacidic base, okay, it cannot be used to prepare basic salts. Okay, so to prepare basic salts, more than one OH minus has to be present in the base. Okay, then only partial replacement of OH minus by acidic radical. Okay, so how basic salt can be formed? By partial replacement of OH minus from a base by acidic radical, right? So when an acidic radical replaces partially the OH minus present in the base, then we are getting basic salt. So what are some examples of basic salts? We'll see some examples of basic salts. That is CuOH SO4, right? This is a basic salt. Only one OH minus is replaced by SO4, right? And SO4 2 minus is the acidic radical. Previously we had CuOH whole twice. 2 OH was present, right? So we are adding an acid. We are adding an acid, okay, where the base acidic radical of that acid replaces only one OH, right? So if it replaces only one OH, then one OH will be left in the salt, right? And this acidic radical is replacing that one OH. So we are getting a basic salt. So let us recapitulate again. What is a basic salt? A basic salt is something which contains OH minus group in their composition. Okay, so OH minus will be present. Okay, so basic salt can be formed by partial replacement of OH minus by another acidic radical. Complete replacement does not form basic salt. If complete replacement of OH minus occurs, then what will happen? We will get normal salts. If complete replacement of H plus occurs, then we will get acidic salts. Okay, so we are going to see some reactions. Some reactions acidic salts. What are some of the reactions of acidic salts? Is first we will see the formation. NaOH plus H2SO4. We are getting NaH H2CO3 we are taking, carbonic acid. So what is happening? Just see, from this acid we are getting 2H plus and 1 CO3 2 minus, right? So if only one H plus is replaced by this Na plus, Na plus is what? Na plus is the basic radical, right? So if one H plus is replaced by this Na plus, that means this Na plus is taking the place of one H plus, right? So what we will get? Na plus, H plus will be there. I'm breaking the thing and trying to make you understand. Okay, Na plus, H plus and CO3 2 minus. Okay, so when one Na plus is replacing one H plus from here, we are getting, because one H plus is already replaced, so we are getting Na plus and one H plus is left, right? Because there is partial replacement, and CO3 2 minus. So 2 positive charge and 2 negative charge. What we will get? NaHCO3, which is known as sodium bicarbonate. Okay, in the previous class we have seen the sodium bicarbonate reacts with acids, which is also a very popular reaction. For example, HCl plus NaHCO3. Okay, so acid is reacting with sodium bicarbonate to give a salt plus CO2 plus H2O. Okay, so carbon dioxide will be evolved and we will get Briggs effervescence. Briggs effervescence, carbon dioxide will be evolved in the reaction, right? So we'll see Briggs effervescence as we have already seen in the earlier classes, right students? So students, now we'll see the preparation of salt. Okay, there are two types of salts. One is soluble salts and one is insoluble salts. Okay, the salts which are dissolved in water are known as soluble salts, and the salts which are not dissolved in water are called insoluble salts. Okay, so we are going to see the preparation of salt. First of all, we'll see the preparation of soluble salts. Preparation of soluble salts. Okay, so the first method is direct combination. Direct combination reaction. Direct combination. Okay, if sodium in molten state. So what is molten state, students? When this sodium is melted. Sodium is a metal, we all know. So by heating, when this sodium is melted, that melted sodium is reacted with chlorine gas and we will get NaCl, solid. This salt will be produced. So by direct combination we can produce soluble salts. Iron can react with chlorine gas to produce FeCl3, which is also a soluble salt, right? The second method of reaction is displacement reaction. Displacement. Displacement reaction. We all know the activity series. Okay. So the metals which are above hydrogen in the activity series will be able to, so suppose it is the hydrogen. So the metals which are above hydrogen in the activity series will be able to replace hydrogen from an acid. Right? For example, zinc. Zinc is above hydrogen in the activity series. So if zinc is reacting with HCl, what will happen? Zinc will be able to take the place of H in HCl. But if the metal is below hydrogen, right? So it cannot take the place of H in that case, right? So the metals which are above hydrogen here in this reaction are known as active metals because they are actively participating in this type of reaction. Okay, so what we will get, if zinc takes the place of hydrogen, we will get ZnCl2 plus H2 gas will be evolved. We already learned the characteristic of H2 in the previous class. It burns with a pop sound when a matchstick is brought in front of it. Okay. Mg, magnesium also react with HCl to give MgCl2 plus H2. Because magnesium is situated above hydrogen in the activity series. Okay. So magnesium is also situated above hydrogen in the activity series. That's why we are getting this type of reaction, right? Now we'll see another kind of reaction called double decomposition, which is also used to produce normal salts. Double decomposition. Double decomposition. Okay. So under double decomposition reaction we will see three types of reaction. Reaction with carbonates and bicarbonates. Okay. The second is reaction with sulfite and bisulfites. And the third type of reaction is reaction with sulfides. This is sulfite and this is sulfides. Okay, so what will react with all this kind of salts? Okay, acids, reaction of acid. So reaction of acid, right? So acid will react with carbonates, sulfites and sulfides to produce soluble normal salts. Okay, so we are going to see the preparation first process, the reaction of acid with carbonates or bicarbonates. We already know this reaction. Suppose we have an acid HCl plus, we are adding K2CO3. This is carbonate. Let us see another reaction, H2SO4 plus NaHCO3. This is bicarbonate. Okay, why bicarbonate? Because one hydrogen is present, which is an acidic salt. So this can be called as sodium hydrogen carbonate or sodium bicarbonate, right? And this is potassium carbonate. What we will get? KCl plus CO2 plus H2O. Okay, so we are getting one soluble salt, KCl, right? KCl is a soluble salt, and from here what we will get? Na2SO4 plus CO2 plus H2O. Even from here we are getting also a soluble salt, Na2SO4. So how I am writing the formula of this soluble salt? Okay, so we have to understand that from H2SO4 we will get two types of ions. One is H plus cation, always the left hand side part is the cation part. Okay, and another ion will get SO4 2 minus, sulfate ions, right? And from here we will get three types of ions, Na plus, H plus and CO3 2 minus. Three types of ions. Okay, so see, this is your basic radical and this is acidic radical. When the acidic radical is combining with the basic radical, we are getting one soluble salt here, right? You can say that sodium can react with, combine with carbonate. Okay, it will not do that because already this kind of carbonate salt is present. So what is the profit then? We are adding carbonate salt and getting carbonate salts. We are not getting something different. Okay, so this radical will not combine with this one. Okay, this radical will combine with this one to give a new salt, new soluble salt, right? And carbon dioxide is evolved. We already learned the properties of carbon dioxide in yesterday's class, that it turns lime water milky. Right, so these are the properties of reaction of acids with carbonates and bicarbonates by which we are getting another soluble salt, right? Now we'll see the reaction of acid with sulfites or bisulfites. Suppose we are reacting with H2SO4 plus sulfite Na2SO3. This is sodium sulfite. Okay, so H2SO4 is reacting with sodium sulfite. What we will get? We'll get two type of ions here, H plus and SO4 2 minus, right? And from here we will get two types of ions, Na plus and SO3 2 minus. So this two will combine, Na and SO4. So what we will get? Na2SO4 plus H2O plus SO2, right? So this is a gas. SO2 is a gas which will be evolved. Same, you can compare both the reactions. If acid is reacting with sodium carbonate, okay, then we are getting sodium sulfate plus water plus CO2. Okay, but in case of sodium sulfite, only in place of CO2 we are getting SO2. This is how you can remember it. Okay, so simply both the reactions are same, only they are differing in the products. In place of CO2 we are getting SO2 here. Okay, so how we can identify SO2 in this reaction? What is the process to identify this SO2? There are two kind of things. Okay, one is KMnO4 solution. It is purple in color. Purple in color. Okay, so when this SO2 gas evolving in the reaction is passed through this KMnO4 solution, this purple color become colorless. So SO2 can change the color of KMnO4 to colorless. Okay, there is another procedure, that is orange acidified K2Cr2O7 potassium dichromate. The color of this solution is orange. Orange. When SO2 gas is passed through this solution, what will happen? The color will change to green. Wow. So orange is getting changed to green. So we are getting the indication that SO2 gas is getting evolved. Okay, that's how we can identify SO2 gas. Okay, these are also important for your analytical chemistry portion, that is also in your syllabus, because there you have to identify gases like this. How we can identify carbon dioxide, how we can identify SO2, right? How we can identify H2S, that we are seeing in the next reaction. In the same way, H2SO4 can also react with bicarbonate also. Suppose we are taking potassium bisulfite. So it will react as K2SO4 plus SO2 plus H2O. Here also SO2 gas will be released, same reaction. Okay, and this SO2 gas can change the color of KMnO4 solution, and it can change the color of acidified potassium dichromate solution, right? Now we'll see another kind of this reaction, double decomposition, is reaction of acids with sulfides. We are taking zinc sulfide. Okay, we are reacting zinc sulfide with, suppose we are reacting with HCl. We are reacting zinc sulfide with H2SO4. So what we will get? ZnCl2 plus H2S. This is what? H2S is a gas. Okay, and its smell is foul smell. The smell is very bad. Okay, by inhaling the gas, okay, by taking the smell, you can easily understand that H2S is present in, H2S is getting evolved in the reaction. It can spread in the whole laboratory, right? It can diffuse in the whole laboratory and everyone can get the smell. Okay, it smells like rotten drain. Okay, rotten drain where H2S is produced, right? So such kind of foul smell is produced when H2S is released in the reaction. In this reaction, we will get ZnSO4 plus H2S. Okay, again H2S will be released in this reaction and we can identify the gas by its smell. It is foul smelling gas. Foul smelling gas, right? Okay. Another type of reaction that is very common to us, how we can get soluble salts, is by neutralization reaction. This procedure 4, by neutralization reaction. So it can happen in two ways. Okay, acid can react with a soluble base, water soluble base. Okay, NaOH, which is water soluble, and it can form NaCl plus H2O. Okay, but some bases are there which are not water soluble, like HCl can react with copper hydroxide, which is not soluble. In the last class we studied that the bases which are soluble are alkali and bases which are not soluble are non-alkaline bases. Okay, they are simply bases, not alkali. So HCl can also react with insoluble bases, and this is soluble, to produce CuCl2. A salt will be produced and water will be produced. So what is our target here? We have to prepare soluble salts. Okay, so this method can be used by neutralization reaction, where an acid can react with a soluble base or an insoluble base to produce salt and water. Okay, and the salt is insoluble salt is produced here, right? Another example can be like this: PbO or magnesium oxide. This is also an insoluble base. What we will get? MgCl2 plus H2O. We are getting a soluble salt, preparation of soluble salt, right? So by neutralization reaction, acid can react with either a soluble salt or insoluble salt to produce another soluble salt and water, right? Another reaction for the preparation of soluble salts is bases reacting with metal. Reacting with metal. Okay. So what is this kind of reaction? For example, Mg is reacting with Zn is reacting with NaOH. Okay, Zn is reacting with NaOH, so we will get Na2ZnO2, sodium zincate. Okay, as we have seen in the first reaction, right, metal reacts with acid to produce salt and what? Salt and hydrogen gas. Also, bases will react with metals to produce salt plus hydrogen gas. And we can detect the hydrogen gas easily, right? Aluminium can also react with bases NaOH to produce Na2AlO2. Sodium aluminate. Sodium aluminate plus H2 will be produced. Right? So bases can react with metals, active metals. Active metals, if non-active metals like gold, platinum, this type of metal reacts, then there will be like very less chances to react. So we need active metals which reacts with bases to produce salt and hydrogen gas. Okay. So these two reactions are also very important. Finally, we will see the preparation of insoluble salts. Okay. So how insoluble salts are prepared? The first method of preparation is reaction between metallic oxide and non-metallic oxide. Okay, so we know what is metallic oxide? Metallic oxides are always basic oxide. Okay, and non-metallic oxides are acidic oxides. Okay, so metallic oxide is reacting with non-metallic oxide to produce a insoluble salt. Suppose CaO, calcium oxide, it is a metallic oxide or basic oxide. It is reacting with sulfur dioxide. As we all know that it is responsible for acid rain. It's present in the atmosphere and mixing with water to produce sulfurous acid, which is falling as acid rain on earth, and it is occurring too much damage. So this is acidic oxide. So what will happen? This basic oxide is reacting with acidic oxide to produce calcium sulfite. Calcium sulfite will be produced, which is an insoluble salt. I already told you what is insoluble salt. The salts which are not soluble in water. Okay. And there is another method of preparation of insoluble salt, and that is double decomposition reaction. And we already know that one type of double decomposition reaction is precipitation reaction. So precipitation reaction is a type of double decomposition reaction. Right? We all know that precipitates are insoluble salts. Suppose BaCl2 is reacting with Na2SO4. BaCl2 is reacting with Na2SO4. So double decomposition reaction means these two anions will change place. Either these two anion or these two cations will change place, right? And what we will get? Ba2 plus will combine with SO4 2 minus. So we'll get BaSO4, and Na plus will combine with Cl minus. So we will get NaCl. Now here BaSO4 is insoluble. It is suspended in the solution as precipitate. So it is white precipitate. And we all know that precipitates are insoluble in water. Okay? Precipitates are insoluble in the solvents. Right? So we are getting insoluble salt by precipitation reaction, but this is a soluble salt. Okay? So we are getting insoluble salt by precipitation reaction. Again, another type of reaction is AgNO3 plus NaCl. What will happen? This Ag will combine with Cl, and this Na will combine with NO3, and we will get another precipitate of AgCl, which is white in colored, white PPT. Okay. So white PPT, it is also a precipitate, and we are getting insoluble salt, right? So this is how we can prepare soluble salts and insoluble salts. And salts have lot of industrial applications are there, and we will see some preparation of some specific important salts in the next classes. And till now we have discussed our salt portion this far. Thank you.